As a chemist, I look mostly at the nutritional composition of the black soldier fly larvae, and that means that I look at the proteins, the amino acids, the fatty acid profile, and the total lipid content. And also, I'm currently focusing on chitin quantification. So I determine the amount of chitin that I find in the black soldier fly larvae. Chitin is a polymer, and it is found in the exoskeleton of insects. So in my studies, I have seen that high levels of chitin can have negative effects on fish health. So therefore, we want to extract it. And that can improve the use of black soldier fly meal in fish feed. And the extracted chitin we can use for all sorts of possibilities. We can use it in agriculture, we can use it as a bioplastic, we can use it as a pharmaceutical. So then you upgrade sort of the usage of chitin in a good way, and the fish will also be happy because it's not in their feed. Chitin can impair the digestion, just like other fibrous materials in the intestinal tract, and therefore can reduce the uptake of the nutrients into the body, and the body weight eventually will go down. Small amounts of chitin can be used in fish feeds to modulate the immune system. So you can actually make fish respond better when they are exposed to a disease. At a certain moment, the positive effects that we see on the immune system are found at a certain dose, but once you go over that dose, it might have negative effects on the digestion and will reduce the growth of the fish. In my research, we are looking for the tipping point where we actually go from the negative to the positive effect. So you would quantify chitin to know what the level of chitin is in the samples that we have. So the protocol consists of 3 main steps, and what we first do is we will remove the protein, and then afterwards we will demineralize the samples, and lastly we will determine the amount of glucosamine in the samples that we have done. So after we have frozen the larvae, we have grinded them into a meal that you see here. I have used this sample and remove the protein using sodium hydroxide, and then it's ready to use for chitin quantification. I have put in some of the larvae meal inside, and then I have added hydrogen chloride, and after 24 hours I take the samples out. So chitin we cannot measure directly because it is also incorporated in a lot of proteins and minerals. It will have bonds with them. So what we need to do is to determine the glucosamine, which is the monomer of chitin. And the amount of glucosamine that we determine is directly linked to the amount of chitin in the sample. So I'm testing 3 different meals, and then I compare it to a control where I know that there is a lot of chitin in it. And it's very important in most of your research to have a good control group so you know that your method is working. So I will take these 2 chemicals and take 1 milliliter of each in each of the different vials, and this is for the start of the determination of glucosamine. So now I will add 1 milliliter of ammonium sulfamate to each of the samples. And it has to be done really slowly because you will see some foam formation. So now I am adding the METH, and that will make a blue color when it interacts with iron that we add in a later step. And now we have to leave it for 60 minutes to make sure that they interact, and then afterwards we can add the last chemical. So now I'm adding the FeCl3, which is a bit of a yellow compound, and I will add this on top of all the samples, and I do another 1 milliliter, and then it will give a blue coloration if you leave it standing for around half an hour. And you can see clearly that there's differences in the coloration. So here we have the negative control, which is a bit blue, but that is because there is some background coloration. The two meals with the lowest chitin content are much lower in blue coloration than actually the meal with the high chitin content. And the really intense color is the positive control, which we also expected to have a really blue color. So now I'm gonna determine the glucosamine content in the samples by measuring their absorbance in the spectrophotometer. And with the amount of glucosamine that we determine, we can calculate back how much chitin was originally in the sample. When I have obtained the data from the absorbance values, then I put them into my Excel files. And in the Excel files, I use Lambert-Beer's law to determine the glucosamine content. Chitin is a very interesting compound because we know that we can use it in a lot of different fields. We can use it in agriculture, we can use it in medicines, and therefore extracting chitin will be very essential in the future to be used as a natural substance in improving our health and well-being.
Den her video er en del af et undervisningsmateriale, og du kan finde mere information på verdensmålene.dk.